The unit weight test is a very important tool used to control the quality of freshly mixed concrete. After a concrete mix proportion has been established, a change in the concrete's unit weight will indicate a change in one or more of the other concrete performance requirements. A lower unit weight may indicate that the material has changed, a higher air content, a higher water content, a change in the proportions of ingredients, and/or a lower cement content. Conversely, the higher unit weight would indicate the reverse of the above-mentioned concrete characteristics. A lower unit weight from the established concrete mix proportion would generally indicate an overyield. This means that the required cement content for a cubic yard is now diluted to produce a greater volume of concrete. Therefore, lower strengths are to be expected, as well as a reduction of the other desirable qualities of the concrete. If the reduction of the unit weight of the concrete was due to an increase in the air content, possibly the concrete will be more durable in its resistance to cycles of freezing and thawing, but its strength, abrasion resistance, resistance to chemical attack, shrinkage, and cracking qualities of concrete will be adversely affected. The unit weight test must be used to control lightweight and heavyweight concretes. A change in unit weight could adversely affect the pumpability, placeability, finishability, and strength of all types of concrete. As with any hydraulic cement concrete testing, always wear the minimum proper protective equipment required. In this video, we will demonstrate a unit weight test using the pressure meter bowl, which has a volume of approximately 0.25 cubic feet. The capacity of the measure utilized is dictated by the nominal maximum coarse aggregate size. ASTM C138 allows the use of a metal, glass, or an acrylic strike-off plate. We will use an acrylic strike-off plate in this video. The sample must be obtained in accordance with ASTM C172, sampling of freshly mixed concrete. When testing concrete with a slump less than 1 inch, an internal vibrator must be utilized for consolidation. When testing concrete with a slump greater than 1 inch but less than 3 inches, rodding or internal vibration is allowed. Concrete with a slump greater than 3 inches must be rodded. Determine the mass of the empty measure. Dampen the interior of the measure and place it on a flat, level, and firm surface. Remove any standing water from the bottom of the measure. Fill the mold in 3 equal lifts. Rod each lift 25 times uniformly over the cross section with the rounded end of the rod. While rodding the first lift, rod the layer throughout its depth using care not to damage the bottom of the mold. After rodding, tap the outside of the mold 10 to 15 times with a rubber mallet to close any holes left by rodding and to release any large air bubbles. For the second lift, rod the layer throughout its depth and approximately 1 inch into the previous lift. After rodding, tap the outside of the mold 10 to 15 times with a rubber mallet to close any holes left by rodding and to release any large air bubbles. For the third lift, rod the layer throughout its depth and approximately 1 inch into the previous lift. After rodding, tap the outside of the mold 10 to 15 times with a rubber mallet to close any holes left by rodding and to release any large air bubbles. After consolidating the third layer, an approximate 1/8 inch of excess concrete above the top of the measure is considered optimal. Representative material can be added or removed as needed prior to strike-off. Strike off the top surface of the concrete and finish it smoothly with the flat strike-off plate, leaving the measure level full. Place the strike-off plate on the top surface of the measure to cover 2/3 of the surface. Withdraw the plate with a sawing motion to finish only the area originally covered. Place the plate on the top of the measure to cover the original 2/3 of the surface. Advance it with a vertical pressure and a sawing motion to cover the whole surface of the measure. Continue to advance the plate until it slides completely off the measure. Incline the plate and perform several strokes with the edge of the full measure. Completely clean the exterior of the measure and determine the mass of the measure filled with concrete. Report the volume of the measure to the nearest 0.001 cubic feet. Calculate the unit weight as follows. Unit weight equals full measure weight minus empty measure weight divided by the volume of the measure. Immediately report and record the unit weight to the nearest 0.1 pounds per cubic foot.